Properties of definite integration. As there are number of properties in definite integration, some properties are related to the limits of integration, and some properties are related to variable containing integration. As these three properties are, first three properties are on limits of integration. As first property says that if both limits, upper limit and lower limit, are same, then integral has a value always equal to 0. See the simple property, as upper limit and lower limit is same, so upper value and lower value is equal. As we take subtraction of both, so the subtraction will be 0. That means the value of integral will be 0. Second property is again a simple property, as this property is in which we have divided the integral, as integration from a to b of f of x dx is equal to integration from a to c plus c to d. You can understand here as a is a less than c, or less and c is a less than b. Okay, I have made one mistake. A to c to b. Okay, that means c is a in between number of upper limit and lower limit. Then we can change the interval of limit as a to b to a to c to c to b. Similarly, if a is a less than c, less than d, less than b, then interval ab can be changed, divided into interval from a to c plus c to d plus d to b. Okay, so this is again a simple property. And last property is an interesting one which we use frequently. As you can here observe, the on left hand side integration has a limit from a to b. On right hand side the limits are interchanged from b to a of integration f of x dx. What is the change? You can observe here the sign of integration on left hand side is a positive, on right hand side it is a negative. So this property states that if the limits are interchanged, the sign of integration changed. Or we otherwise say that if sign of integration changed, then limits of integration are interchanged. Okay, now the next three properties are on variable containing the integral. As x is a variable, in first property, as you observe, here the limits are same from a to b on both sides, but variable x is replaced by t. Then we take integration with respect to t. This is a simple property as we observe in substitution method. As we take integration x with respect as term of x with respect to x, then we have to take integration of t term of t with respect to t. Now limits are same, function is the same, so integration has the same value. Okay, now fifth and sixth properties are important for exam oriented. As you can observe here, on both sides integration value is the same, as equality is there. But what is the change here? As you observe, on right hand side we change the variable of a function by a plus b minus x. That means addition of limits minus x. The value of integration does not change, as limits are remain as it is or constant in both the integration. So this property states that in integration, definite integration, variable x of function is replaced by addition of limit minus x, then the value of integration does not change. Okay, and the sixth property is the same, as lower limits is 0, so addition of limits is a 0 plus a is a, and x is replaced in integral as a minus x. The value of integral does not change, and we have an example to solve on these properties. These examples are to solved by using properties of definite integration. As you can observe here, these are the fractions containing radical sign, that means root, cube root, fourth root, fifth root, or nth root like terms. And these terms are in a pattern in which a numerator has a single term which is repeated in denominator. As you can observe in first example, root x is in numerator, as denominator contains plus root of x. Similarly, cube root of 9 minus 6, denominator contains cube root of 9 minus 6. So you can observe the these examples and define these are define these examples to solve by using properties. As there is a special method to by which we can solve this example. As in first example, I put integration is equal to I take this integration as a 1. Remember the procedure. Now by property, write the statement by property number 5, x replaced here by addition of limit, as limits are 1 and 2, so 1 plus 2 minus variable x, that is 1 plus 2 minus x, that is 3 minus x. Now simply replace x in integral by 3 minus x. So though does not change the limits, as limits are on integration 1 to 2, the term of x in numerator in root, so x root of x is replaced by 3 minus x. Similarly in denominator, in first term 3 minus, actually x is replaced by 3 minus x, so we use bracket as there is a subtraction between two terms, plus, and last term again 3 minus x. Now algebraic simplification is needed here, as there is a subtraction or addition of terms. So as in numerator term remain as it is. Now in denominator, as this bracket is simplified, we get plus 3, get minus 3, and minus minus plus x, as these terms are in root. Okay. Now, and last term in denominator remain as it is into dx. Now simplification again, taking subtraction, as numerator is a 3 minus x and denominator is a simply plus 3 minus 3 get cancelled, we take term as a root x plus root of 3 minus x. Now the algebraic simplification is complete. Now you can observe here the term which is in denominator in addition of term in numerator is now in numerator. Okay, and both integral has the same denominator, as terms are only interchange, as here root 3 plus root of 3 minus x plus root x, and here is denominator root x plus root of 3 minus x, that is terms are only interchange. Now put this integral as number 2. Remember these steps. Simple algebraic simplification by using property we made. Now remember, we have to use this integration by solve by using properties of definite integration. We add equation 1 and 2. Now addition of equation, you know there are two sides on in equation, left hand side and right hand side. So we take first addition of left hand side of both equation, or as there is I on left hand side in both equations, so I plus I become 2i. Okay, and now on right hand side the addition of integration is required, as you use the properties as you use the rule of integration. We stated that if addition is there, then you separate the integration. We reverse the rule. It means if addition is there, we can take integration of addition by taking addition of terms in integral. Same in definite integration, we use if limits of both integral are same, then we can take addition of integral and take its integration with common limits. As you observe in integration 1 and integration 2, the on right hand side both integral has the same limit from 1 to 2, 1 to 2. As we have to add this integral, we take the same as the same common limits from 1 to 2 and add the integrals. As you observe, the integral contain a fraction with common denominator, so we take only addition of a numerator and take a common denominator. So in first integral we have numerator root x plus, in second we have a numerator root of 3 minus x, and common denominator as is equal to the as it is in numerator, that is root of x plus root of 3 minus x into dx. Now numerator denominator is common, so it get cancelled, so we get 1 in integral. Now integration of 1 is always with respect to is x with limits as a 1 to 2. As we know, if x is in bracket, so we take subtraction of limits only, so we get 2 minus 1. Now this 2 minus 1 is a value of left hand side is a 2i. Okay, so we get 2i is equal to 1. Now we have to find this integration which is represented by I, so we have to find the value of I only. We here calculated 2i, so by taking 2 on right hand side we get the value of I, which is a 1 by 2. So first integration has the value 1 by 2. Similarly remaining integration can be solved.